Hi guys, welcome back. So last time we just confirmed that we can detect the apple and get the center coordinate of it. So next we're going to try to get this line and get the average point of this line. So when there's a case like 2 apples or multiple apples. So let me just copy the code. Let's try copy apple detection to apple detection. Let's call it test 2. Okay. Then subrime apple detection test 2. Now we have two completely same script, same code. But I just want to keep this as a backup if we mess up something, so we still have the correct one. So what I'm going to do here is I'm going to define the XC list and then YC list. We want to reset the XC list and YC list every time in the while loop. And we're going to store the XC and YC into the XC list. XC list dot append XC and YC list dot append YC. So I want to use the NumPy array in that case. So after we plot this, let me put it here. So out of the for loop, then I would like to check that if length of x equal to 1, equal to 1. In case of length of x is equal to 2 or 2. So I just want to find, because in the list there might be one that bigger than another one. So I want to find out which one is bigger. So in that case, I'm going to use x max. And then the real x max. Now we can know that which one is max, which one is min. So we can do something like we can find a slope. So you might wonder why I put the difference of x before the y, the difference of y. Basically, the slope in the Cartesian coordinates, you put the difference y upper and then divided by difference of x. But because in the CV frame, the axis is reverse, so to get the correct slope, we need to put the different x upper and then divided by difference of y. So I will show you this later. So let's try to print it out. And the f string. So let's also draw a line. Yeah, because that's what we want to see. And also we want to draw this black circle, which is the average. Just that's it first. Then SCP, going to copy Apple detection test2 to the just nano. Okay. Then let's try switch to just nano. Now we have two files. Test2. Okay. Okay. If I do it like this, you will see that the slope, the m, is negative, and it's like with the big number. But if I make it more straight, you will see that the m become closer to 0. And then once the line back to this side, the slope will be positive and getting much more slope. You will see the number will getting bigger. Yeah, in case of that, if we want to use the slope, we can get the correct value. Okay. By the way, yeah, we can see that the middle point of the line showing correctly the average point. So if in case of if length of x is more than 2, what we're going to do in that case is like this, or maybe more, 4 or 5. So we need to find the best fit line that can like fit those points of the apples, and that method is the least square. So for the NumPy, there is if you try to search here, NumPy.algebra least square. Yeah, there is a way that you can get the slope and the intercept when you have like many points. So yeah, this is explain how you can do that. So I'm going to come to here. We can get the slope and the intercept from that line equation. So we want to know the max min of the line that we have. So we're going to define it like this. And then we can make the x average. So if it detect nothing, then else would be x average. X average is equal to minus 1.0. So basically, the x shouldn't be a minus number. So in case of it couldn't detect anything, it will give the x as minus. Then that could give some sense to the card control parts. If x average is minus 1, it means that the card should stop. Yep, I think that should be okay for this. Then we're going to try to copy this to the JSON Nano again and switch back to JSON Nano and try run it one more time. So if there is 3 apples, you could see there is more than 2 apples. then the point and the line will like generate by try to fit those points as much as possible. So it looks like this. So if this apple is here, for example, then yeah, the point will look like that. It's kind of like fit the best. But anyway, we can prove that our algorithm is working. Okay, so we have proof that the algorithm of detecting the apples and try to find a line to best fit those apples is kind of work. So next we're going to convert that code to ROS2. Then we're going to publish that XC as the ROS topic. So, and then we're going to make another card control program to subscribe to that topics and then do something with the car. So next, let's try to copy the apple detection test 2 into apple. I will put it as ROS.py like this. So if you have ever made a ROS node before, this step shouldn't be that difficult. So you just need to make like a class of the program that you want to run. For in ROS2 documentation, they suggest to make like a class and then put our code inside there and using the timer callback to run it in the loop. So what I'm going to do now is I'm going to import an RCL pi. So we're going to use the standard message. We're going to publish only one value, so that should be enough for now. We're going to define like a main function with the args equal to none. I found that we need to put the die statement in here, and die statement equal to die dot device, and put the pipeline. So we need to make this apple detection class on top here. So we're going to put this def AI configuration as the global variable, and we define it outside. So we have defined this already, so I'm going to remove this die statement, and I'm going to create class which call apple detection. I'm going to define self.die statement and pass with the argument of die statement here. So the other things here we're going to use in init, but we need to put a self. So I would like to say it like pub and sub, the publisher and subscriber from the ROS. So what we're going to publish is the xc pub equal to self.create publisher. So publisher, and we are using float 32 with the topic name as a detection slash xc. So in case if we need slope or other value that want to publish, we can put it inside the detection here. So it will be like well managed. So queue size is 10. Then I'm going to define the XZ message as float 32. Then timer period is 0.02. So 0.02 means the 1.1 over. So it's 50 Hertz. So this should be fast enough for the dev AI. Here, I'm going to define self timer and self.create timer and put the timer period and the self.timer underscore callback. So this should be like our while loop. So we're going to define timer callback. And we just first display it locally. We need to publish the XZ, right? Here, lastly. So this, we're going to publish the X average all the time. So even there is object or not. So if there is no object, it's going to publish -1. So the card can recognize that there is no object, then it should stop. We can try to copy this code to the robot and then try to run it again with ROS. We should have 3 files. Yes. Depends on 3. Apple detection, ROS.py. Hope there should be no error. Okay. Oh, cool. No error. So it shows start Apple detection. And yep, it's printing something. Just some print statement that we just put there. So what I want to confirm is that we should have the ROS topic of detection XZ showing. Yeah. So here we can try to ROS2 topic echo this one. So yep, there's nothing, then it should show -1. But once there is something, it's going to show some coordinates of the object. For example, like here, the point here is around 980 something. So the frame here is 1280. So if I put it very, very close to the edge, so you will see that it's close to 1000 something. Yep. And here should close to 0. So now you can see that we can have the detection XZ topics publishing all the time. So we can make the card control code to subscribe on that. But before going to that, I want to make sure that we can have a stream back to our laptop. So once the JSON Nano is plugging back to the robot, so we don't have the screen of the JSON Nano anymore. So we couldn't see how the robot is seeing on from the camera. So I want some way to stream that videos back to my laptop and display here. So I will try it out on the next video. So please stay tuned.